How's it going, guys? Mr. Puig checking in. So what I want to do with this ed puzzle is I want to start connect everything we've been learning about to the external engine of the Earth. And what we've talked about so far, the major concepts are light. Okay, and that's where the math came in, right? So we talked about electromagnetic radiation. So electromagnetic radiation is pretty much the fancy word for light. It's a scientific name for light. And within electromagnetic, well, we'll talk about that more in a second. Let's just kind of break it down. So we talked about light, and then we learned about the equations of how light converts to energy, or how much energy light can even carry within it. And then we also talked about Earth systems. So how does all of this, so really the question we're trying to answer right now is, how does all of this connect with this? So that's what we're trying to answer. And before we go any further, what I want to actually show you guys is, some of you actually may have seen this. You can see some of these pictures I have down in the bottom right. And basically tonight, which is Thursday night, and you guys are going to be watching this Friday, but Thursday it was raining, as you guys know, and I took this picture from my backyard of this double rainbow. And it was right before I was about to make this video, and I was like, oh my gosh, I got to throw that in, because we know, what are we seeing here in this rainbow? We're seeing the visible light spectrum broken up, right? And what is causing that to happen? Well, if you remember, it's the rain. It's the water. The water is acting like a prism, and as light past the sun's light, which is white light, passes through a prism, it breaks it into its various colors, and that is because, if you remember, that's because of, I'm going to make it an end puzzle question right here. So anyway, you should have answered that it is it's the water changes or breaks up the wavelengths of the light. And so that's how we see the different colors. And so you see red, yellow, and you can kind of see a little bit of blue and maybe purple, but just a beautiful, beautiful rainbow last night. Hopefully some of you guys got to see it in person. Okay, so, and then I got to show you this other picture, of course. Ella's first rainbow. If I can get it to enlarge. There we go. There she is, enjoying her first rainbow. And you can see how massive it is. It's so cool looking. But yeah, that it's funny, because that's exactly what we've been talking about with electromagnetic radiation. So Ella says, oh, can I write on there? I heart EM waves. Love, Ella. She just wrote all that. She can already write. Just kidding. But anyway, so, let me enlarge that again. Well, I can, well, that's kind of cool. I can move all this stuff. So, let's get back to business here. So, let's talk about the first thing in wrapping this up. So, we've been using this analogy of an engine. Okay? And for good reason. So, hopefully you guys all know about car engines. You've seen under the hood of a car before. And so this is our engine here. And we know that car engines are very complex. Okay? And so the analogy we're using is, and let's just kind of break it down for you. Light is what? What do you think light would be in referring to a car or an engine? Well, if you said the fuel, then that would be correct. Okay? So that's the light in our analogy from the sun is like the fuel in a car. And what would be the engine? Or sorry, so what would be considered our engine in this analogy? Well, that would be it would be Earth systems that we just talked about. And so basically the connection we're trying to make is as light hits the Earth and all of these various systems working together, it's like when fuel is fueling an engine. As you can see, so the engine takes in the fuel, and it can, if you've ever been in a car, you know that fuel can be transferred into many types of energies, including lights, and it can power the lights in your car, which are powered by a battery, but that engine, the fuel energy is being used to turn the alternator to fuel the battery. So if you know anything about cars, electrical energy to start the car, and obviously the heat energy that helps turn the pistons with those little explosions that help turn the pistons. If you don't know much about cars, don't worry about it. Just know that the reason this analogy fits is because an engine is very complex and it relies on many systems working together, just like Earth systems. And what fuels that is the light. Okay, and so that's why we started with light. So that's going to be important. So, let me try to move this without moving everything here. So I'm going to get rid of that stuff, and hopefully you guys can So that's really the first thing, was the engine analogy. Okay, and then the next thing I wanted to talk about is, and I accidentally wrote on it, is going to be this concept of thermodynamics, right? So thermodynamics, some of you may have heard of. So what I want you to write down in your notes is this definition of thermodynamics, and specifically we're going to be talking about the first law of thermodynamics. Okay, but let's first break down what thermo means. Thermo equals heat, and heat is a form of, so we'll just say slash energy. Okay, and dynamics equals change. So what we're looking at is how heat changes, okay, and or how energy changes. And the first law of thermodynamics states that energy really doesn't get destroyed, which we already knew. It's just like matter. Matter cannot be created or destroyed. Energy can neither be created or destroyed. It just transfers from one type of energy to another. So heat energy can be transferred to electrical energy or chemical energy. And this is very important because this is the major physical science concept we are talking about when we are looking at the external engine of the Earth. We want to know how light from the sun, this is really what we care about. How does light from the sun interact with Earth's external engine and produce various types of different energies? So when light interacts with our system, Earth system, and that's also why we talked about different types of systems. So let's go ahead and break that down again. So let me throw this out of the way, and we will talk about that. So the next thing we talked about was types of systems. If you remember, that was in one of your ed puzzles. Okay, and Earth really, depending on where you go, so there was isolated, if you remember that, and hopefully, maybe a quick quiz question could be, what was an isolated system? Hopefully you remember. And there was closed, and then there was open. So when we're talking about the different systems of Earth, Earth is going to be all three in different locations. Now, if you're on the surface of Earth and you're looking at weather happening around you, then you're going to look at that weather as transferring heat and energy. So, from the surface of Earth, I'll put this down here, to an observer on the surface of Earth, it's going to look like an open system, because not only is energy transferred, so we could write that here. Energy is transferred. And I'll put a check mark next to it. And actual physical material is transferred, which we could just say is matter, and a check mark. Maybe I'll make this check mark green. Okay, but then if you're an observer from outer space, you may only see energy transferring. So if you're from outer space, Earth is going to be and I'll turn that back to red, Earth will be a closed system. And this would be, say, from outer space. So it all depends on the observer. And that would be only energy. And we see this because we know light travels into Earth, and that's about it. Now, you could, if you really wanted to get technical with it, you could say meteors are coming in, and, but that's a very minimal impact. It's not like we're getting hit by huge asteroids every day. But if you wanted to be absolutely technical, then you could say, even from looking from outer space, if you saw meteors crashing, then actually technically the whole thing would be open. But we like to define our systems for simplicity. So when we're talking about Earth systems, or the different types of systems, we're going to specify if we're talking about it from outside of the Earth, outside of, say, Earth's atmosphere, then we're going to call it closed. So we'll just go ahead and say that. And then if we're talking about it from on the surface of Earth, we're going to say it's an open system. Okay, if you're an observer from on the surface of the Earth. And then isolated, we won't talk about it, but there are places that could act like an isolated system on Earth. Maybe if you were in, if you were buried underneath a bunch of rock that was really good at insulating you, then it would act more like an isolated system. But even then, matter would probably be transferring. We're just not going to even deal with isolated for now. That might be more of when you take a chemistry class. So those are the different types of systems we talked about. Okay, and to be more specific about our types of systems, we're going to do types of systems. So let's talk specifically about what systems we are going to be focused on for the rest of this unit. So these are our 4 systems, correct? 4 systems. And if you remember, hopefully you do remember, this is our geosphere. I'm not going to write the whole thing out. This is our biosphere. This is our hydrosphere. And this is our atmosphere. So you just add a sphere to each of those. So when we're talking about our external engine, really all of these are an external engine, but the 2 we're going to be focused on are our hydro and atmosphere. So you need to know that. That's what we're going to be focused on for the rest of this unit. So where we're going to be going in the next couple weeks is we're going to talk about the hydrosphere. And we'll talk a little bit about it in this lecture, but we're really going to dive into it in the next couple weeks. Same with the atmosphere. So these 4 systems, so the 2 systems, the hydrosphere and the atmosphere, is where we're going to talk about our external engine. So hydro plus atmosphere are going to be the focus of our external engine. So the big question is, when light, or maybe I'll even make it yellow. Well, let me finish writing. So when light travels into Earth, and we're observing it from the surface of Earth, as light travels into Earth, okay, we want to answer the question, how does this light energy change in the hydrosphere? So what does it do in the hydrosphere? And what does it do in the atmosphere? So this light energy is going to transfer differently. Okay? And I might as well just finish writing that out. So the big question is, how does this energy change? And we're going to be treating this like an observer from Earth, okay, or from the surface of Earth. So we're going to treat this as a closed system. Okay, so we're going to say this is a closed system where only light is able to enter. And that's what we're going to be focused on for now. And then we want to look at how this affects the planet. So light comes in, light energy comes in, and then we have some energy coming out of the system as light and other, maybe even heat. Okay, and I'll make that red. But we're going to be focused on this. Okay, so we're going to do just a couple more notes here and wrap it up. So, we're going to talk about, first let's talk about the hydrosphere. Well, actually, before we even talk about that, I want to talk about, gotta find it, where'd it go? Whoa. I want to talk about this concept right in here. And this is something you guys should know from, and we'll title these notes right here, or put it in your notes, different types of energy. We'll put 2 different types of energy. So no matter what energy you're talking about electrical, you're talking about light energy, you're talking about heat energy, whatever it is, chemical energy, this energy will always be in one of 2 forms. It will be in potential energy, so we'll say P, we call that PE, potential energy, and that is for potential energy. Okay, and then there's also KE, and that is kinetic energy. And you should have learned about this probably in middle school in 8th grade, especially when you guys I know a lot of you guys did the roller coasters. If you had Mrs. Gutman, we talked a lot about this in that class. And you guys mainly talked about what you've learned so far is kinetic energy. Kinetic energy for the movement of an object is 1/2 mv squared. Now don't worry about the math for now. In fact, don't even worry about really writing this down for now. I don't really care about that. We will come back to it in the future, for sure. And then but I just want you to understand this potential energy that you've talked about, it has to do with gravity. So both of these situations refer to these 2 equations. So when the biker is traveling up, he has kinetic energy, but as his kinetic energy starts to slow down and he stops at the top, he has only potential energy, right? And then as he starts coming back down the energy, that potential energy is being transferred back out as kinetic energy. So as you can see, it just is going back and forth. Energy just goes back and forth between potential and kinetic energy. Okay? And that's all we care about right now. And so in this case, so the really big thing you need to understand is that potential energy doesn't just have to do with gravity, and it doesn't just have to do with the movement of an actual object. They can both actually be defined for any type of energy, and that's important. So chemical energy can be stored in chemical bonds, or it can be stored as kinetic, or it can be released, and you see the chemical reaction, and that's kinetic energy occurring, right? So the energy is actually changing. You can have it in electrical energy. So you can have batteries store energy electrically, and you can also have batteries store energy or release that energy electrically traveling through wires, and then it would be kinetic energy. So as you can see, almost any form of energy, same with light. So any form of energy we see, that you can have kinetic or potential energy. So you just need to understand that energy can be stored, and it can be, and then it can be, transferred. And in the process, you have potential and kinetic energy. So hopefully that concept makes sense to you. And I needed to cover that because the last 2 items we're gonna cover are, we're just gonna briefly cover, and then we'll be really talking about them more as we get in there. So in the hydrosphere, how does energy? So really, what we're going to be answering as we go forward is how does energy transfer in the hydrosphere? That's the big question we're going to be asking. And what you need to know right now is that water is very good at storing energy. And this is very important to life on Earth. Okay? So you could actually connect this property that water is very good at storing energy, say from light. So when light hits water, that water absorbs all that energy. Okay? And this is very good for every sphere of the Earth. So we could talk, and we will talk later on about how this affects, the geology of the Earth, and we'll kind of pull everything together. But you need to know this for now. And what we're going to be discussing in the next couple weeks is why is this? So we're going to be looking at the chemistry of water a little bit. Okay? And then another thing we need to know, and this will be the last piece of notes for today, is that, so the last thing, and remember, the external engine we're going to be talking about right now is the hydrosphere, because we're looking at weather, right? So, I mean, that's what you got to remember. We're looking at the weather, and that really has to do, I mean, even in the next couple of days, we're getting a lot of bad weather. That's a mixture of atmosphere, right? The clouds being the atmosphere, high and low pressure systems, etc., and how that affects. So the atmosphere also stores energy. So the atmosphere is made up of, so let's take a couple notes on the atmosphere now. So I'm going to put the atmosphere in black. Let's just put it in black, because most of the atmosphere is clear anyway. The gases are all see-through, so can't really draw that. But anyway, so let's talk about it. So the atmosphere is made up of mostly gases, whereas the hydrosphere was made up of, obviously, the hydrosphere is actually made up of all three, solid, liquid, and gaseous water. But the atmosphere is made up of primarily gases. Okay? And these gases do trap energy. And hopefully some of you can kind of see where I'm going with this. So what we're talking about right now, what we're talking about with water, is potential energy, right? So the storing of energy, trapping the energy. This would also be known as potential energy. And some gases are much better. So you can kind of see, like I said earlier, you can see where I'm going with this. Some gases are better. Some gases trap that energy. And they can convert that energy to, say, heat energy. So some of you, again, will be talking about global warming later on, and that'll be a main cause of it. So, and then what you need to know is that, so water can store energy, the atmosphere, the gases can store energy. And then we want to know, why is that? Again, we want to know, why are they storing this energy? So again, looking at a little bit of the chemistry, but then also what happens, so this is another question, and we're not going to be actually answering these questions right now. It's just something I want you to start thinking about as we move into the next couple weeks. So what happens when this potential energy goes to kinetic energy? What happens? Well, I'll give you, okay, so I said I wasn't going to answer it, but I'll give you a brief answer. Okay, this is where you get storms, right? And rain. And many other things that you see in the weather. Okay, so let's just recap really quick, draw a quick picture, and then we'll be done. So remember, light from the sun. So light from the sun hits the Earth, and we're going to pretend right now that the Earth is purely a closed system from the ground. Or sorry, I think I actually said, so we're going to try to just focus on the energy for now, not necessarily the matter. So the light penetrates into the Earth, okay, and then the hydrosphere and the atmosphere take that energy, and they transform it into different types of energy. So you get all these different, so you get transformations of energy. So the hydrosphere and the atmosphere transform the energy, transform the light into different forms of energy. Into, we could say, heat energy. We could say electrical energy. You guys have seen lightning before. There was actually lightning yesterday. So heat, electrical, and as well as others. So that's what you need to know for now. And I think I need to make a quick addendum. I think I said we're going to be treating Earth as a closed system, and that's where I kind of stuttered. So we're actually going to be treating it as a somebody from the ground. So somebody that is on the surface of Earth, and we will be treating it like an open system. So I think earlier I said it was a closed system. You might want to go back and change that. We're going to be treating it like it's an open system because we want to look at how does this energy transfer to matter. So like rain and different types of matter, mostly within the hydros, and gases. So yeah, so that was a quick addendum I needed to make to that. So we'll go over this in class if anything was kind of confusing. But I just wanted you to know these major concepts. This is how everything we've been learning about recently within your ed puzzles kind of connects back to our essential question and our unit. So, so be prepared for a discussion on this. All right, I'll see you guys later.